Welcome to my channel Hari PS videos. Right. So thanks for subscribing my channel and watching my channel. So many times I requested you and also requesting please watch the videos, the topics which are going in your school, right? Then you will understand well. Thank you. Then let's start our session today. Previous session we discussed extraction of metals of high reactive metals. Extraction of high reactive metals. So high reactive metals are available in the combined state with chlorides and oxides. The chlorides and oxides. So by the process of electrolytic reduction or by the process of electrolysis, so we are able to extract them. Then coming to the second category of metals means extraction of medium reactivity metals are moderate reactive metals. So moderate reactive metals are given zinc, iron, lead and copper. How these moderately reactive metals are extracted from their respective ores. So the moderately reactive metals which are in the middle of reactivity series are extracted by the reduction of their oxides with carbon, aluminum, sodium or calcium, and the concentrated ores can be converted into metal oxide by the process of calcination, roasting and smelting. And one more process also is thermite. Metal oxides, right. Then one more process also is the thermite process. So these are the four processes are there. How we get the concentrated ore from the metal oxide. So as already we discussed in the flow chart, extraction of medium reactive metals are 4x4 methods we have to get that one. So reduction of metal oxides with carbon, reduction of self reduction, then one more reduction of oxides with carbon monoxide. So moderately reactive or chemical reduction, auto reduction, displacement method and electrolytic method. So means oxide of metals you get a different process. So let's understand one by one. Mostly some of the moderately reactive metals occurs in the natures as oxides, but others occurs as their carbonates or sulfides. Mostly available in the nature by the carbonates and sulfides. These carbonates and the sulfides are easily converted into oxides by some reduction methods, by some reductive methods or by following some methods. So they are already discussed: chemical reduction, I already told you, chemical reduction, auto reduction, displacement reduction and electrolytic reduction. So by the process of these carbonate ores and sulfide ores are converted into metal oxides. Then these metal oxides are From these metal oxides, we have to get a concentrate. We have to get a concentrated both by the process of calcination, roasting, smelting, and thermal process. So let's understand one by one by one, and these methods, the reduction of the oxides with carbon, aluminum, sodium, or calcium. Let us understand one by one. Reduction of metal oxides with carbon. Reduction of metal oxides with carbon. Right. Reduction of metal oxides with carbon. The oxides of comparatively less reactive metal like zinc, iron, nickel, tin, lead, and copper are usually reduced by using carbon as the reducing agent. In the reduction by carbon, the metal oxide is mixed with the carbon and heated in a furnace. So furnace is a furnace. All the reactions are taking place in the furnace. There are different types of furnaces. Then we will discuss them. Oxides of comparatively less reactive metals. Oxides of comparatively less reactive metals. So first of all, we have to discuss about metal oxides. Metal oxides also available, and the carbonates also available, and the sulfides also available. So for oxides different methods, and for sulfides and carbonates are different methods. So reduction of metal. Reduction of metal oxide with carbon. Reduction of metal oxide with carbon in the first process. The first product, you can say that chemical reduction. So the oxides are reduced by coke. Coke nothing but one of the product obtained by coal. As we know, coal consists of mainly carbon, and coke has the purest form of carbon. No other impurities are present in that. So the oxides are reduced. Metal oxides are reduced by coke in a closed furnace, which gives the metal and carbon monoxide. Let's take one example. Zinc oxide. Zinc oxide plus carbon is nothing but in the form of coke. So this is a carbon. So this carbon displaces the oxygen from the zinc. So zinc plus carbon monoxide. So this is carbon monoxide, and zinc is formed. So zinc oxide is a metal oxide. So this is called as zinc oxide. We have a name that is zincite. Then let's take one more example. Lead oxide plus carbon. So what will happen here? Lead and carbon monoxide is formed. So here the metal oxides. So reduction of metal oxide with the carbon. Zinc oxide plus carbon, zinc plus carbon monoxide. Here zinc oxide is reduced by the carbon and forms zinc plus carbon monoxide. Similarly, lead oxide reacted with carbon, so forms and reduce lead and carbon monoxide is formed. Then iron metal is extracted from oxide or hematite by reduction with carbon in the form of coke. Tin, lead metals are also extracted by the reduction of their oxides with carbon. Even though less reactive, metal copper is extracted by the reduction of oxides with the carbon. So zinc, iron, tin, iron also. Iron, hematite, Fe2O3 is a hematite. Is ore of iron is also reduced by the carbon. So zinc oxide, lead oxide, iron oxide, tin oxide, copper oxide, all are reduced by the carbon. Reduced by the carbon. Then reduction of metal oxides with aluminum. Reduction of metal oxides with aluminum. So that process is being called as the thermite process. Thermite process. Thermite process. Thermite process or reduction of metal oxides, reduction of metal oxides by aluminum, reduction of metal oxides by aluminum. A very very important process. This is thermite reaction. Thermite reaction. So thermite reaction, the one of the very very important reaction. So the reaction of metal oxide to form metal by using aluminum powder as reducing agent. The reaction, the reduction, sorry, the reduction of metal oxide, to get the reduction of metal oxide to form metal or to get metal, to form metal by using aluminum, is called thermite process. So this thermite process is a highly exothermic reaction. It is highly exothermic reaction. Means a huge amount of heat energy is liberated. During the thermite process. So the reduction of magnetic oxides with aluminum, iron oxides are reduced by using aluminum. So that reduction of metal oxides with aluminum is called as a thermite process. So thermite process is a highly exothermic reaction. As we know, exothermic reaction. So if heat energy liberate any chemical reaction, so we can say that exothermic reaction. So this property of the aluminum made in the thermite welding for joining the broken pieces of heavy iron objects like girders, railway tracks, or cracked machine parts. How this reaction takes place? So iron Fe2O3 plus aluminum. As we know, aluminum is more reactive than iron. So aluminum is more reactive than iron. We get Al2O3 plus iron. Is formed, and a huge amount of heat energy also forms. So Fe2O3, Al2O3. So here we can write 2. So 2 Al. So 2 aluminum right, its physical states. So solid, sulfur, then liquid is formed. It is a solid, it is also solid, then liquid is formed and it is also solid is formed. So this liquid iron is used to fill the cracks of broken iron pieces, broken iron parts between the railway tracks, or any machinery parts, The molten iron is then poured between the broken iron pieces, to weld them. So how the reaction happened, then this way the reaction takes place. See how this is takes place. How So the thermite process takes place like this. So the step 1, aluminium welding takes place. So the this part is filled with liquid iron. So after that, what will happen? The proper welding takes place here. So this process. So completely this process is called as a thermite reaction. And chromium also we have to place. So figure 3a observe that thermite reaction is going on. So a liquid of iron is formed. That liquid of iron is poured between the broken iron tracks or railway tracks, and then welding is formed. So this process is called as a thermite process. And one more reaction also showing the chromium oxide, aluminum oxide plus chromium, and heat also produced. So these are the metal oxides. These metal oxides are reduced by the aluminium. So that process is called as thermite process. Right? So then similarly magnesium oxide also. So 3MnO2 plus aluminium gives Al2O3 plus manganese. So 3 So 3 manganese and Al2O3 2. So 6 are there. So here we can write balanced chemical equation. MnO2 manganese oxide plus aluminium we get Al2O3 plus Mn, and as usually heat energy liberated, because during thermite process more heat energy is liberated. So such reaction is called as exothermic reaction. So Al2O3 3, then 2 oxygens there, and write 2 here, 6, then we write 3 to the 6, 3 aluminium. So 3 manganese and 4 aluminium. So this such reaction is called as thermite process. Reduction of force. This method also is called reduction of force by more reactive metals. Reduction of force or compounds by more reactive metals. So aluminum is more reactive than iron. Aluminum is more reactive than magnesium. Aluminum is more reactive than zinc, lead, copper. So especially in case of aluminum, that process we can call as the thermite process. A more reactive metal like aluminum can also be used as reducing agent. So already we see here by reduction of their oxides with carbon So in this way we get metals. Then we get metals. Reduction of oxides with carbon monoxide. Then auto self reduction of sulfide ores. Auto self reduction of then auto self reduction. Auto self reduction. By the self reduction copper sulfide Cu2S copper sulfide. So and in the extraction of copper from its sulfide ore, the ore is subjected partial roasting in air to give oxide. When the supply of air is stopped and the temperature is raised, the rest of the sulfur reacts with the oxide and forms the metal and sulfur dioxide. Okay, auto self. Then by the process of auto self reduction. So auto reduction of sulfur or self reduction of sulfide ores in the extraction of copper. From copper sulfide ore, the ore is subjected to partial roasting in air. So this CuSO4 is combined with oxygen. It forms CuO and sulfur dioxide. 2 CuO2 plus 2 SO2 form. Cu2O, SO2, 3 units, then copper 2, sulfur 2, oxygens are different. Then we can write the correct equation. 2 Cu2, 3 O2. 2 Cu2, 3 O2. So 4 carbons, 4 O2, 2 like. So 2, then 2 sulfurs, 4 carbons, 2 oxygens plus 2 fours, 4 plus 2 6, 2 3 is 6. Then after this Cu2O, then this Cu2O. When the supply of air is stopped, the temperature is raised. The rest of the sulfide reacts with the copper oxide and forms the metal. So this Cu2O again combined with this and gives us copper plus sulfur dioxide. So here the copper sulfide ore involved in self reduction. When we heat it in the partial supply of oxygen or air. So the partial roasting, we will discuss what is meant by roasting, calcination and smelting. This is a self reduction. Reduction of oxides ores with carbon monoxide. So Fe2O3 plus CO. It forms iron plus carbon dioxide. Okay, we will discuss this reaction with this process, calcination, roasting and smelting. So ferment process completed. Then we have calcination, roasting and smelting. So I hope you understand this. So moderately reactive metals. Let's understand what is calcination, roasting, smelting. So metal oxides from the metal oxides. So metal oxides are reduced by the carbon, aluminum, sodium and calcium. So then understand what is meant by the calcination, roasting and smelting. So calcination means The concentrated ores can be. Calcination is the process in which carbonate ore. It is the process. It is the process. Carbonate ores. Carbonate ores. Carbonate ores is carbonate ore is heated. Carbonate ore is heated by the carbonate heated is heated strongly. Heated strongly in the absence of air. In the absence of air. In the absence of air. So is called calcination. Simply, it is the process carbonate ore is heated strongly in the absence of air. In the absence of air and form metal oxide. So converting carbonate ore into metal oxide. So metal oxides are easily reduced by carbon, aluminum or some other elements. But carbonate and sulfide ions, carbonate and sulfide metal ores, carbonated ores and sulfide ores must be converted into oxide source. So because of oxides are easily reduced by carbon and aluminum. So calcination is the process in which a carbonate ore is heated strongly in the absence of air, convert into metal oxide. So zinc carbonate, for example, zinc carbonate, Zn CO3 is heated in the absence of air. It converts into zinc oxide plus carbon dioxide. So it is a solid and it is a gas. So strong heating, calcination, you can write here directly, calcination. So zinc carbonate is a carbonate ore. Carbonate ore is heated in the absence of air. Then this zinc carbonate is converted into zinc oxide. So thus calcination convert the zinc carbonate into zinc oxide. So similarly, then any other also they are heated in the absence of air. They are also heated in the absence of air, and they also convert into their respective metal oxides. Right. Then roasting. So roasting is the process. It is the process. Sulfide ores are strongly heated. It is the process in which sulfide ore is heated strongly in the presence of air. In the presence of air, and in the presence of air, convert to metal oxides. In the absence, so calcination is involved for the carbonate ores. Roasting is involved for the sulfide ores. So sulfide ores are converted into metal oxide ores by the process of roasting. Roasting is the process of sulfide ores are strongly heated in the presence of air. In the presence of air, then they convert into metal oxides. So, for example, ZnS, zinc sulfide. Zinc sulfide, it is a solid heated strongly in the absence of air. Heated strongly in the absence of air. So, nothing but it reacts with oxygen. So, plus oxygen, it gives zinc oxide plus sulfur dioxide. Zinc oxide plus sulfur dioxide. So, 3 oxygens here. So, we can write 3, 6. Then we can write 2, 4. Again, we can write 2 here. Then 2 here. So, 2 ZnS, 2 zincs, 2 sulfur, 3 2 just 6 oxygens, 2 oxygens, 4 oxygens, 4 oxygen. So, sulfide ores reacts with oxygen, nothing but strong heating in the absence of in the presence of air, forms zinc oxide and sulfur dioxide. Zinc oxide and sulfur dioxide. Zinc oxide and sulfur dioxide. Previously, the self reduction and auto reduction also. Here I wrote, I told you. So, copper sulfide ore is heated, involved in partial roasting. Partial roasting means little supply of oxygen. So, it converts copper oxide. This copper oxide is again combined with leftover copper sulfide and forms copper. Leftover copper sulfide and carbon. So, self reduction. Then, so calcination is used for heating the carbonate ores to convert metal oxides. Then roasting is used for sulfide ores to convert the sulfide ores to metal oxides. So this is about the calcination and roasting. Then one more process is smelting. It is meant by smelting. Smelting is one of the process. So, smelting is a pyrochemical reaction. Pyro means heating process, in which the ore is mixed with the flux and fuel and strongly heated. The heat is so strong that ore is reduced to even metal, as in the case of iron, and the metal is obtained in a molten state. Smelting is a pyrochemical process. Smelting is a pyrochemical process in which the ore is mixed with flux. The ore is mixed with flux and fuel strongly heated. So strongly heated, then the metal oxide is directly converted into metal. So here one word I have to use is flux. What is meant by a flux? Flux meaning. So Flux is the substance, is the one impurity. Flux is the impurity. Flux is the substance added to the ore to remove the gangue from it by reacting with the gangue. Reacting with the gangue. So flux is the substance. Flux is a substance. Flux is a substance added to the ore, added to the ore to remove the gangue, from it by reacting with the gangue. So here, as we know, any impurity present in the ore, we can call as a gangue. To remove the gangue, sometimes we have to, in some cases, for some methods, we have to add another one. So that substance which is used to remove the gangue or impurity from the ore is called as a flux. So here what will happen? By the process of smelting, when we add the flux, so it removes the gangue. If the impurity is acidic substance like SiO2, basic substance like calcium oxide is used as a flux, and if the impurity is a basic nature like SiO3, like FeO, acidic flux is SiO2 is added to the gangue. There are two types. So if the impurity is a basic like iron, magnesium oxides, we should use SiO2. Then if it is acidic like SiO2, basic substance like calcium oxide is used. So SiO2 is a acidic gangue. So if SiO2 nothing but silica nothing but sand, SiO2 is a impure substance in the ore. To remove this acidic gangue, so we have to use calcium oxide as a flux. If it is FeO, iron is a basic gangue. We have to use SiO2 as a flux. So to remove the impurities from the ore, we have to add one substance. That substance is called as a flux. So acidic flux is used to remove the basic impurity. Then the basic flux is used to remove the acidic impurity. So by adding flux, smelting is a pyrochemical process in which the ore is mixed with the flux and fuel strongly heated. When we heat the flux and the ore strongly, we get metal oxide. So let's understand the smelting process. Smelting. How the reaction is taking place. How the reaction is taking place. The heat is strong that the ore is reduced to even metal as in the case of iron, and the metal is obtained in molten state. During smelting, the impurities in the ore react with the flux to form slag, which is removed. Slag means nothing but a waste material. So, for hematite ore, coke is used as a fuel and limestone used as a flux. The smelting carried out in a specially built furnace known as blast furnace. Blast furnace. So, the reactions inside the furnace are, so in case of smelting, especially for iron, so to get iron, so hematite ore, coke is used as a fuel and limestone used as a flux. So by the process, so this hematite, from the hematite we get iron. So this flux is combined with impurity and removed as a slag. Then the iron is formed as a molten state, as a liquid state. So this reaction, the smelting reaction is carried out. Especially constructed furnace we can call as blast furnace. So here I will show you the picture. So roasting takes place in the reverberatory furnace. Different furnaces I will show you here. So if it is possible, then I will show you some picture also. I will share the picture. So this is a blast furnace. See, different parts are there. Waste gases, alternating layers of iron ore and coke, hot air, molten iron is formed, molten slag is formed, different temperatures are also formed. This is a blast furnace. This blast furnace is used to for smelting process. For roasting, there is another furnace is a reverberatory furnace. So roasting is a pyrochemical process in which the ore is heated in the presence of oxygen or air. So zinc sulfide. So this is about the reverberatory furnace. Right? So in this way we have to extract the medium reactive metals. Right? So in this termite process is a very important. So this is about extraction of medium reactive metals. Thank you. I hope you understood.